Welcome back to CognitionChunks. Yellowstone Day 4 Part 1. I failed to set the date correctly on my camera. August 25th, 2022 was actually September 21st, 2023, whoops. We called an audible and decided to visit the Midway Geyser Basin today because it was predicted to rain. And maybe even snow the next few days according to the information posted in registration by the rangers. So we followed the figure 8 southwest, past Norris, toward Old Faithful, where we made a brief stop at Beryl Springs. Then went to Firehole Falls where we saw an osprey in its nest. National parks like Yellowstone serve as vital indicators of the Earth's climate health. These areas are relatively undisturbed by human activities compared to other landscapes, providing a unique opportunity to study climate change in a quasi-control setting. The effects seen here can be extrapolated to understand larger patterns in ecosystems, geology, and climatology that are increasingly influenced by human activities. Metrics used for barometrics. Long-term temperature records can show subtle yet significant shifts. Changes in rainfall or snowfall can indicate climatic shifts. The size and mass balance of glaciers in parks can serve as climate indicators. Shifts in animal behavior often reflect changes in environment. Timing of flowering, fruiting can be a clear indicator of environmental change. Water quality like changes in pH, pollutant concentration, and water levels in lakes, rivers, and ponds. Ice cores these can reveal historic levels of greenhouse gases. Soil composition samples can show long-term shifts in nutrient and mineral content. An increased frequency and intensity of wildfires can indicate drier and hotter conditions. Invasive species, their presence and success can indicate a changing, often less stable, environment. Air quality, changes in pollutant levels and their distribution patterns. Trends over the past 10 years. According to the National Park Service, NPS, the average temperature in Yellowstone has increased at a rate approximately double that of the global average over the last decade. A noticeable increase in wildfire events, both in frequency and intensity, has been documented. Some wildlife species have begun migrating to higher elevations to escape the heat. The few glaciers in Yellowstone are retreating at an accelerated rate. There's been an uptick in invasive species, which threaten native flora and fauna. Trends over the past 50 years. Temperature records dating back 5 decades show a trend of increasing average temperatures, albeit at a slower rate compared to the last 10 years. Rivers like the Yellowstone have shown a decrease in water levels, affecting fish populations like the cutthroat trout. Earlier flowering and fruiting times have been observed, a phenomenon corroborated globally. Changes in hibernation times and feeding patterns among large mammals like bears and wolves. Trends over the past 100 years. Over the last century, the size of glaciers in the greater Yellowstone ecosystem has reduced considerably, confirming global trends. While air and water quality were relatively pristine a century ago, the intrusion of pollutants like nitrogen and sulfur compounds has been noted, though the situation has improved since stricter regulations were introduced mid-20th century. There has been a slow but steady shift in the types of tree species that dominate the landscape, partly influenced by temperature and partly by human activities like fire suppression. Over the last century, Yellowstone has seen the extirpation and then reintroduction of species like the gray wolf, which has significant ecological ramifications. Expanded metrics. In colder regions, the melting of permafrost layers provides crucial data on soil temperature and the release of methane, a potent greenhouse gas. Analysis of sediment in lakes and ponds can reveal past climate conditions, often going back thousands of years, through the presence of certain minerals and organic matter. Monitoring the timing of when ice breaks up or melts in rivers and lakes during spring can offer additional data on temperature changes. For parks near coasts, the acidity levels in the water serve as important indicators of CO2 absorption from the atmosphere. Isotopic ratios in water bodies and tree rings can offer robust markers for temperature and precipitation histories. Palynology, the study of fossil pollen to determine past climates and vegetation. Remote sensing, utilizing satellite technology for high-resolution monitoring of vegetation, snow cover, and land use changes over time. River discharge and stream flow modeling, in-depth hydraulic modeling to analyze changes in river systems, particularly useful for understanding snowmelt contributions. Dendrochronology, the study of tree rings, which can reveal yearly variations in climate. Deeper dive into trends. Past 10 years. Advances in genomics allow for the study of how climate-induced stress is affecting plant and animal genomes in the short term, which may have longer-term evolutionary impacts. Cryosphere monitoring, new technology allows for more precise measurement of glacier thickness and snow cover. Albedo measurements, changing land cover, especially from snow to vegetation or rock, alters the Earth's albedo, reflectivity, which can contribute to temperature changes. Recent studies have started looking at shifts in the soil microbiome as it's affected by climate. This is critical for understanding nutrient cycling and soil health. The distribution of plant species across altitudes and latitudes has shown noticeable changes, indicating their struggle or adaptation to new climate conditions. Despite being protected, there is increased anthropogenic pressure due to higher visitation rates, possibly linked to last-chance tourism, which may interfere with the park's role as a climate indicator. Past 50 years. Long-term ecological research, LTER. This methodology has provided multi-decadal datasets, crucial for distinguishing between natural variability and anthropogenic impacts. Microclimate studies, the study of localized climates within the park, has unveiled nuance in how different ecosystems are responding to broader climate changes. Sediment diatom analysis, these microscopic algae in lake sediments can be powerful proxies for past nutrient levels and pH conditions, showing how water bodies have been altered over time. 50-year datasets show changes in migration patterns of birds, which are highly sensitive to environmental changes. A marked increase in extreme weather events has been noted, affecting everything from animal behavior to vegetation cycles. Older studies didn't focus on carbon sequestration, but recent analysis has shown a decline in the park's effectiveness in capturing and storing carbon. Past 100 years. Paleoclimatology, researchers are employing various paleoclimatic techniques to reconstruct historical climate conditions, using everything from sediment cores to historic photos for verification. Phylogeography, this combines the study of evolutionary history with geographic distributions to understand how species have responded to climate changes. Endemic species, over a century, certain species unique to Yellowstone have shown vulnerability due to climatic and environmental changes, some facing extinction. Geothermal activity, though the relationship is complex, long-term observations suggest that geothermal features like geysers and hot springs show variability potentially linked to broader climate patterns. Blackfeet creation narratives. Napi creation. One of the key figures in Blackfeet creation myths is Napi, also known as Old Man. He is often considered a creator deity but is also characterized as a trickster figure. According to one account, Napi created the world from a handful of mud, fashioning the earth and populating it with animals and humans. He also is said to have formed the rivers, mountains, and other geological features. Dualism and the roles of animals. Napi often interacts with animals in these myths, highlighting the significance of human-animal relationships in Blackfeet culture. For example, in some accounts, it is Wolf who suggests to Napi the creation of human beings or who helps him shape the world. Themes of morality and law. Napi's adventures often serve to explain the origin of various natural phenomena, but they also provide moral and ethical lessons. For instance, the manner in which Napi treats others in his stories is reflective of principles of justice, respect, and social decorum. Cycles and transformation. The Blackfeet narratives often include elements of cycles, including life, death, and rebirth, emphasizing the natural order and balance in the world. Myths about locations in Yellowstone. Sacred mountains. In Blackfeet cosmology, mountains are often considered sacred spaces that are closer to the spiritual realm. While specific myths about Yellowstone's mountains from the Blackfeet perspective might not be widely documented, mountains in the region are likely to be associated with various myths, rituals, and perhaps even specific deities or ancestral spirits. Water bodies, rivers and lakes are crucial in many indigenous myths, often symbolizing life, renewal, and the passage between worlds. Given Yellowstone's rich array of water bodies, it would not be surprising if they figured into Blackfeet mythologies, perhaps as dwelling places of spirits or as locations for significant mythical events. Geothermal features. Yellowstone is well known for its geothermal features like hot springs and geysers. While specific Blackfeet myths about these features are not well documented in public sources, such unique natural phenomena are often integrated into indigenous mythologies as the work of gods or spirits. Complexity of character. Napi is not an omnipotent or infallible deity. His actions often lead to unintended consequences, and his behavior can swing from benevolent to deceitful. This complexity serves to represent various aspects of human nature and the unpredictability of life itself. Creation methodology. Napi didn't just create the world in the sense of crafting it ex nihilo, out of nothing. He engaged with existing elements, mud, stone, water, to shape and mold the world. This aspect could be seen as a proto-scientific understanding of materials and elements. Partnership with animals. It's not just that animals are helpers to Napi. Sometimes, they serve as teachers or guides. They are integral to the process, underscoring the interconnectedness of all life. Thank you for joining us for another CognitionChunks episode. Please like and subscribe.